Hello learners, Quality Engineering and Management, Week 8, video number 27. The topic is House of Quality, HOQ and 7 Management and Planning Tools. Presented by Dr. N. Venkateshwarlu, Associate Professor, Mechanical Engineering, School of Engineering and Technology, Indira Gandhi National Open University, New Delhi. The House of Quality. There are two dimensions that affect the success of design effort: the extent to which a product or service design meets customer needs and how well an organization can produce or deliver the design. QFD is a way to evaluate how well the product or service design and the operation process meet or exceed the needs of customers. Using competitors' offerings, an additional part of the assessment helps the organization to identify both where they need to improve and also the product and service features and activities that are non-value adding. Learners, objectives. After listening this video lecture, you should be able to understand House of Quality, describe the 6 basic steps of building House of Quality, explain 7 management and planning tools. Learners, these are the objectives of this video lecture. The House of Quality. The complete QFD approach involves a sequential set of matrices through which the links between customer needs and the technical component, material and operation requirements are identified and maintained. The QFD process begins with studying and listening to the customer to determine the characteristics of superior product. So QFD is utilized to develop to understand the needs and requirements of the customer, and which will be converted into technical requirement and then operational requirements, and which will be utilized to develop a better product which is having superior quality. Through market research, the consumers' product needs and preferences are defined and broken down into categories called customer requirements. One example is an auto manufacturer that would like to improve the design of a car door. Through customer surveys and interviews, it determines that 2 important customer requirements of a car door are that it stays open on hill and is easy to close from the outside. So these are the customer requirements for a car door. So after the customer requirements are defined, they are weighted based on their relative importance to the customer. Next, the consumer is asked to compare and rate the company's products with the products of competitors. This process helps the company determine the product characteristics that are important to the consumer and to evaluate its product in relation to others. The end result is a better understanding and focus on characteristics that require improvements. Customer requirement information forms the basis for a matrix called the House of Quality. By building a House of Quality matrix, the cross-functional QFD team can use customer feedback to make engineering, marketing and design decisions. The matrix helps the team to translate customer requirements into concrete operating or engineering goals. So that QFD team has to work to identify the customer requirements and customer characteristics through building a House of Quality matrix. The important product characteristics and goals for improvement are jointly agreed on and detailed in the house. This process encourages the different departments to work closely together, and it results in a better understanding of one another's goals and issues. However, the most important benefit of the House of Quality is that it helps the team focus on building a product that satisfies the customer. So it is the house of quality is important is to bring the total requirements into the product, the customer requirements into the product, so that the customers will be satisfied. The house of quality, the 6 steps for building house of quality. So there are different steps, which are: 1. Identify customer attributes. 2. Identify technical features. 3. Relate the customer attributes to the technical features. Evaluate competing products. Evaluate technical features and develop targets. Determine which technical features are to display in the production process. So these are the 6 steps which will be detailed further. Step 1. Identify customer attributes. So identify the customer actually demanding or actual needs through their voice. Identifying true needs of the customers. Customers are different, so their needs will be different. So identifying each individual customer's attributes is a big task. For example, suppose a car manufacturer, there are different car manufacturers are there, but a person is a manufacturer, suppose he is developing an engine, so he has to satisfy each and every customer. So here that is the importance. So for different customers, different needs will be there. So that is individual customer requirements, customer needs to be identified, and each customer should be satisfied. So second, technical features. Prepare a list of the technical features and that will meet the customer requirements, and also known as design attributes as per designers. These attributes form the basis for subsequent design, manufacturing and service process activities. They must be measurable because the output will be controlled and compared to the objective targets. So some targets will be there. So first, whatever we have identified through these processes, QFD, house of quality processes, that requirement should be compared with the targets we planned. So that is the technical features of a house of quality. Then third point is relate the customer attributes to technical features. House of quality roof shows, it is a house of quality we are saying. In the roof shows the interrelationships between any pair of technical features. A relationship matrix will be developed showing the relationship between customer attributes and technical features. The relationship matrix helps in assessing whether the final technical features adequately addresses the customer attributes and will be based on customer responses and expert experiences. Evaluating competing products. In this step, the rating of each customer attribute and evaluating existing products on each attribute will take place. This rating represents the areas of greatest interest and highest expectation to the customers. This competitive evaluation helps in identifying the strengths and weaknesses of competing products. It also an opportunity for the designers for improvements. So this step 4 will help the designers as well as to identify and compare the differences of the requirements of the competitors and with our target requirements. Evaluate technical features and develop targets. In the 5th step is accomplished through in-house testing and translated into measurable terms. This evaluation step is performed to find out the inconsistencies. Targets for each technical features are set on the basis of customer important ratings and existing product strengths and weaknesses. In the 6th step, determine which technical features to deploy in the production process. So now in the up to 5th step, we have identified the customer requirements and we have converted into technical requirements and which are also which are need to be deployed in the production process. So which technical features to be deployed in the production processes. In the final step of house of quality, identify the characteristics that have the strong relationship to customer needs and strong selling points. These are the characteristics needs to deployed in the design and production process and to maintain the voice of the customers. So in these 6 steps we have learned about, first we have to identify the customer needs and which are to be converted into technical requirements, and these technical requirements will be can be deployed in the production processes. Then the 7 management planning tools. The QFD quality function deployment utilizes many tools such as market research, benchmarking, focus house of quality, etc. In addition to these tools, QFD utilizes 7 management and planning tools. In many of its procedures, these are affinity diagram, relationship diagram, hierarchy trees, matrices and tables, process decision program chart, that is PDPC, analytical hierarchy process and blueprinting. So in the quality function deployment, it is a process which utilizes various tools to enhance the quality of the products or development of a new product. It uses various tools. So these are the 7 management and planning tools. So first one is affinity diagram. So this is a powerful method used by a team to organize and gain insight into a set of qualitative information such as voiced customer requirements. Building an affinity diagram involves the recording of each statement onto separate cards, which are then sorted into groups with a perceived association. A title card which summarizes the data within each group is selected from its members or is created where necessary. A hierarchy of association can be achieved by then sorting these title cards into higher level groups. So affinity diagram is a diagram which it is a tool to familiarize or to make some about 4 to 5 or 5 to 10 people will be involved. This is known as a cross-functional team. It is utilized for the quality function deployment. So for that, this affinity diagram is created. So in this affinity, how to create the affinity diagram? So people involved and they will write on the card their views about that problem or the new product development. So all like that, everybody gives the cards and all the cards will be pulled and separated according to their according to similarities. So that's why we have affinity. So which are the cards are similar, which will be separated one place, like that. So some groups will be sorted out. So in that we can identify which are the requirements. So for example, in determining the quality costs, the team will list various elements in a random fashion. So whoever gets the idea, he will write it on the card and give it to the leader. So like that. So once many ideas have been generated, so all the people will give so many ideas. So all generated ideas will be pooled. Once many ideas have been generated, they can be grouped according to their affinity or relationship to each other. This technique helps managers and engineers focus on key issues and their elements rather than an unorganized collection of information. An example of affinity diagram is shown in figure 1 in the next slide. So this is an affinity diagram. Here we would like to find out poor quality costs. Which are poor quality costs? So to identify that, again through this process, affinity diagram or cross-functional teams, it has developed two different types of equipment cost and failure cost. In the failure cost also internal failure cost and external failure cost. Like that, in the equipment cost, we will see that instruments, for purchasing instruments or calibration of instruments, some cost will be arise. So these costs comes under equipment cost. And the test and inspections. So testing, we use the instruments for testing and inspections. So that is also there. Also one operator will be there, so that also costs something. So this is also comes in the equipment cost. Then computers for process control. So buying computers or for what you can say for process control, or you can say that measuring automatically. So all this comes under the equipment cost. Like that, then failure cost. Failure costs are internal failure cost and then external failure cost. Internal failure costs are involved in the production processes in the industry itself. So that is scrap. While producing the product, some scrap will be generated. So that is also cost. Then rework, some little bit rework will be there. So that is also, again we have to do that. Once we have not produced at a first time, then the rework will be there. So it costs more. So that cost comes under the internal cost. Then downtime cost. Because of that rework or problem, so machine has to be waited for production. So that also comes under the internal failure cost. Then external failure cost. What are those external? It is apart from the industry, not in our industry. So external are complaint investigation. So suppose we have sold a car to the customer, but it gave some problem. After warranty period also, the cost will not be there. So before, if it is in the warranty period, so we have to replace the parts, or sometimes we have to replace total product. So there some cost will be involved. So it comes in the external cost. Then recalls. Nowadays, I think you have seen in the papers, so Maruti has recalled 350 cars back. Hero Honda has brought some vehicles to bikes to its factory again because of some faulty engine or faulty parts are assembled in that. So like that, some recalls we have to call back and again replace the part and send it. So that is unnecessary cost. So these costs comes under the failure cost. Then returns cost. So sometimes the customers will very angry and he says that I don't want this mobile, you take it and give it to me new one, or I don't want your product at all. So such type of costs are involved in failure cost. So because we are failing to satisfy the customer, so that comes under the failure cost. So these are the various costs which we can identify through affinity diagram. 7 management and planning tools. In the second point, hierarchy tree or tree diagram, you can say that. The hierarchy tree or tree diagram also illustrate the structure of interrelationship between groups of statements, but is built from the top down in an analytical manner. It is usually applied to an existing set of structured information such as that produced by building an affinity diagram, and is used to account for flaws or incompleteness in the source data. Working down from the top, a tree can make amendment at each level and the completed hierarchy can be drawn. A tree diagram maps out the paths and tasks that need to be accomplished to complete a specific project or reach a specified goal. From this general statement, a team can be established to recommend steps required to solve the problem or implement the plan. The product produced by this group would be a tree diagram with activities and recommendations for timing the activities. As shown in figure 2 in next slide is an example of some of the key elements in establishing a quality cost system. So this is a tree diagram. So to establishing a quality cost, so which are the points to be noted down? So responsible departments, so quality costs, which are where the quality costs and who are the responsibles, so what are the responsibilities, so all these things through identified through this tree diagram. So the data collection, then comes to intangible costs. So then in the first one, responsible departments, which are the responsible department for the costs involved. So control over reporting process, and you can say that the data collection process, then next in the data collection process, then accounting system, estimation, then special systems if any. So all this comes under the data collection point. Then intangible cost, which are intangible cost, so what to measure, so and coordination with marketing and customer service. So this is the tree diagram. You can see from top, it is horizontal, but you can see from top or you can see as a tree also, then you can easily understand. In the 7 management and planning tools, the third one is matrices and tables. The matrix is a tool which lies at the heart of the many quality function deployment methods. By comparing two lists of items using a rectangular grid of cells, it can be used to document a team's perspective of the interrelationship that exists in a manner which can later be interpreted by considering the entries in particular cells, rows or columns in a prioritization matrix, the relative importance of items in a list, and the strengths of interrelationships are given numerical weights. So by using matrices, one can interrelate. So interrelate the requirements. Suppose a quality requirement, we can say customer requirements can be converted to technical requirements. So all these requirements can be developed through the matrix, and weightage will be given, so that we can understand which relationship having more weightage, so which will be identified through giving the numbers. So this matrix table is already given in the text, so please read the text also. The matrices and tables, the tables are also used in quality function deployment to study the implications of gathered or generated items against a specified list of categories. Examples include production planning and analyzing customer statements in the voice of the customer table. It is also shown in the text, please. So learners, please read the text so that you can able to understand this table easily. Then fourth point is in the 7 management and planning tools, the fourth point, relations diagram or interrelationship diagram. Relations diagram or interrelationship diagram can be used to discover the priorities, root causes of problems and unstated customer requirements. Figure 3 shows an example of how failure costs are influenced by other factors. So relationship diagram is utilized for discovering the priorities. We have so many items, so which one will be the prior? So that is also it will be utilized for that purpose. Then finding out the root causes for a particular problem, and it also used for the unstated customer requirements. So this is the importance of a relationship diagram. So the relationship diagram here, you can see that the relationship between failure costs and rework costs. So which are the rework costs and what are the activities are associated with the failure cost. So by this relationship we can identify through this interrelationship diagram. Preventive costs, then defective units, then number of rework, then comes to cost of not rework. So if we have not done any rework, so how much it cost, and it goes to then failure cost. So this is the relationship of rework costs with failure costs. Then the 7 management and planning tools. The 5th one is process decision program chart. It is also known as PDPC, process decision program chart. This chart is used for studying potential failures of new processes and services. This chart anticipates possible problems and provides countermeasures that will prevent the deviation from occurring or be in place if the deviation does occur. An example of PDPC is shown in figure 4 in the next slide. So this is the PDPC. In this we are finding install quality cost system. For that we need to have some goals. The goal is the install quality cost system, and then what steps we need to take. So establish installation team. So to find out problem or to find out the one team is required. So that is cross-functional team. Then select trial department. So one department one has to identify. Then if it is solved here or we want to expand, then extend the system. So here next step is what ifs. So here the obtain cooperation of users. We have to get the information, or customers, or in the department we need a cooperation. Then middle management may resistance for that. So if they resist, what you can do? This comes under what ifs. In the similar way, so identify quality costs, and then cost next available. So what cost, if the cost is not available, so what you can do? So if any costs are available in the department, then failure costs are these things, and internal failure costs are these things, then you can do something. But if not there, then what you have to do? This is known as if nots. Then possible countermeasures. If it happens like this, what you have to take? What possible countermeasures you have to take? Then executive order or focus on benefits. These are the important countermeasures. Then in the next place, modify accounting system. So if it is in the quality cost, you are going to find out if the quality costs are not available, then what you can modify the accounting system or direct observation. So through this you can countermeasure the defects. So that is the use of PDPC. 7 management and planning tools. This is in this 6th point is analytical hierarchy process, AHP. AHP uses pairwise comparisons on hierarchically organized elements to produce an accurate set of priorities. So it is a hierarchy. It is a research tool which can be utilized by the researchers, those who are doing research on priorities. So identifying some various factors he may be identifying for a particular purpose. So in that, which are more important, which are to be implemented, so which will be better to implement. If we implement those factors, how the production will be improved, how the productivity will be improved, how the quality will be improved. So this is mostly utilized in the research process. So or in the industry also it can be utilized, the hierarchy, analytical hierarchy process. So it is one application of, I will explain you here. In the industry, the supplier selection process, we have various number of customers will supply so many products to the industry. So in the one product will be supplied by various suppliers. The analytical hierarchy process utilized for the supplier selection process in the industries. So to identify a good supplier or making priorities for the suppliers. If A is a good supplier, B is a better supplier, like that one has to prioritize. So for there we can utilize this analytical hierarchy process. The seventh one is blueprinting. So blueprinting is a tool used to illustrate and analyze all the processes involved in providing a service. So with this, I think you have understood the conclusions. Learners, I hope you understood the concept of house of quality, steps required for building house of quality, and 7 management and planning tools. In the next video, number 28, you will learn about various case studies on application of quality function deployment, house of quality, and 7 management and planning tools, and its impact on the company quality performance. Thank you.